If they do not ask in the first quadrant, you have to calculate both, okay, both the area. That means this area is similar to this area. That is called the symmetry. Now first you have to apply the upper limit and then you have to apply the lower limit. So what they have given next, y is equal to 2. X is equals to 2 and 4 means it is a line parallel to the y-axis. So opposite, y is equal to 2 means it is a line parallel to the x-axis. That's it. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram, Pre-University College, the Temple of Excellence, Mysuru. Dear students, in today's session, we'll be moving on to the new chapter, which is nothing but chapter number 8 called Application of Integrals. And here, dear students, you are going to have session number 1. And what are all the topics under this session we are going to study? It is nothing but area under simple curves. Here, we are going to have area under simple curves means, let me take the curve will be like this. So, this is a curve. So, area under the curve you are going to calculate. Let me draw the line from that curve which is perpendicular to the x-axis and here another line. So, this I am going to name it as let x is equals to A and x is equals to B. Okay. So, this area under the curve we are going to do it or we are going to solve that one. So that is going to be known as the area under the simple curves. So here I have taken the simple curve as in the x and the y axis. So and then here you know this is the origin and here you are going to have between that 2 points of x is equals to A and B called as a stripes. Okay. This we are going to call it as a stripe. A simple stripe, and then you know already sum of all that you can do it in the integration. So sum of all that will be giving you area under the curve. So how we are going to calculate this one? So here limit we are taken from x is equals to A to B and the stripes we are going to name this difference is nothing but dx and this nothing but the y because it is parallel to the y-axis. Okay, so therefore area under the curve dA is nothing but you can have x will be from A to B, so y into dx, where y is equal to f of x, we are having x from A to B, y is nothing but f of x into dx. Similarly, if you are having a curve about the y-axis, this is about the x-axis. Suppose about the y-axis if you are having, the curve will be like this. So, this is a curve you are having. So, this you are going to draw about the y-axis and this is from y is equal to A, y is equal to B. And this is a stripe we are going to have. This is a vertical stripe we are going to call it as and this is a horizontal stripe we are going to name it as and this is nothing but dy we are going to have and this is x because this is parallel to the x-axis and the area is given by integral y from what is that A to B, okay, A to B x into dy where x is nothing but you are having f of y. So y from A to B x is nothing but f of y into dy. Okay, so this is how you are going to measure area under the curve about the x-axis, about the y-axis. Understood? Now, what are all the areas you are going to get under this applications of integral? So, let me know one by one. So, here we are going to get it as parabola. So, parabola equation is given by y squared is equal to 4ax. So, this the parabola will be about the x-axis you are going to have. So, this is origin, that is O. So, this diagram you are going to get it as y squared is equal to 4ax. So, similarly, if you are having, next is nothing but y squared is equal to minus 4ax. So, minus 4ax means ulta. So, this is plus 4ax, minus 4ax means you are going to get it like this, okay. This is minus 4ax and this is a diagram you are going to get it as. So, next you are going to have x squared is equal to 4ay. Now, dear students, if you are having y squared is equal to 4ax and minus 4ax, it is right side to the origin about the x-axis and left side to the origin about the x-axis. Now, if it is x and y variable, change it. So, x squared is equal to 4ay means it is above the x-axis you are going to, this is the diagram of x squared is equal to 4ay. Similarly, if you are having x squared is equal to minus 4ay, yes, your guessing is right, which is nothing but below the origin of the x-axis. This is what the parabola. Similarly, they can ask you like x squared plus y squared is equal to a squared. Which is formula? This is nothing but the circle with the center as the origin. A is nothing but the radius. They can give instead of a as 4. 4 is nothing but 2 squared, you can take it as. So you are going to get it as the circle will be like this and center will be the origin 0, 0 and radius will be as a units. Understood? So this is what you are going to get it as the area of the circle, and then they can give a line and calculate a bounded area. Okay, they can ask you to calculate the bounded area. Similarly, they can ask you a parabola along with the line. They can ask you a circle along with the line. They can ask you area of a triangle to calculate. So these are all the area under the curves you are going to get it as to calculate in applications of integrals. So by knowing this, and also you need to know the area of the ellipse. So ellipse means it will be coming as about the x-axis, about the y-axis. So about the x-axis means you are going to get x coordinate will be greater than y coordinate. For example, if you are having x square divided by 9 plus y square divided by 4. See, 9 is greater than 4. That is x coordinate is greater than y coordinate. So you are going to get the ellipse will be like this. So this is the ellipse which is about the x-axis you are having, and this is nothing but 3, 0 and here minus 3, 0. Okay, and here 4 means 2 squared, which is plus or y squared is equal to 4, y is equal to plus or minus root 4, which is plus or minus 2. So this is 0, 2 and this is 0, minus 2. As accordingly I have taken this one. So it may change according to the given coordinate of the x and the y. So suppose if they give x square divided by, for example, x square divided by ulta 4 plus y square divided by 9. You can see which coordinate is greater? Yes, y coordinates. 9 is greater than 4. The ellipse will be like this. So this is the ellipse you are going to get about the y-axis. Understood? So therefore you are getting here same here, which is nothing but minus 2, 0, x coordinate 2, 0 and this is nothing but y coordinate 3, 0 and here minus 3, 0. Okay, this difference you have to know it to calculate. Okay. So now we'll be moving on to the problem solving, dear students, and here I have taken exercise 8.1 to solve the questions. So here what they have asked, find the area of a region bounded by the curve y squared is equal to x and the lines x is equals to 1 and x is equals to 4 and the x-axis in the first quadrant they have asked. So x-axis in the first quadrant only you need to calculate the area. So y squared is equal to x means it is a parabola. So therefore given curve is a parabola. Correct. That is y squared is equal to x and they have given x is equals to 1 means it is a line parallel to the y-axis. X is equals to 4, it is also the line parallel to the x-axis. So therefore given x is equals to 1 and x is equals to 4 are lines parallel to y-axis. Now you can draw the diagram accordingly, which is nothing but, see, you know already y squared is equal to 4ax. Here 4a is nothing but 1 they have given. So therefore the curve will be getting like this. So this is what the line you can have, and this is a 0, 1, 2, 3, 4. Okay. So this is a y-axis and this is a x-axis, right? And then you can draw the parabola which is about the y-axis, a positive y-axis, and then they have given the line. What is the line? X is equals to 1, which is a line. This is x is equals to 1, which is a line parallel to the y-axis and x is equals to 4. So you can, what is that, extend this diagram. X is equals to 4, which is a line parallel to the y-axis, and they've asked you to find out the bounded region. What is a bounded region? This is. Now this is a bounded region they've asked you to calculate. Especially they've asked in which quadrant? In the first quadrant. Okay. So what is the procedure, dear students? Procedure is nothing but find out the diagram, which I have given the hint accordingly, and then find out the bounded region which is symmetric. I'll tell you what do you mean by symmetric. See, this region is similar to this region. If they do not ask in the first quadrant, you have to calculate both. Okay, both the area. That means this area is similar to this area. That is called the symmetry. Okay, area of the symmetry bounded region you have to find out, and then you have to apply the limit of that integral, and then you have to evaluate, okay, according to the integration. Now here, what is x is equals to? Here, x is equals to 1 and x is equals to 4. I am going to draw the vertical stripes here. See, so I am going to draw the vertical stripes. If I am going to draw the vertical stripes, this is going to be called as the dx, and this is nothing but the y. So area of the integral, you are going to get it as, so area of the curve, area of curve is equal to integral from, where is, I am varying from about the x-axis. About the x-axis from where? From x is equals to 1 to 4 in the first quadrant. So x is equals to 1 will be the lower limit, 4 will be the upper limit. What is that? Y into dx. But what is y, dear students? You have to move to the curve. So therefore here y, you can write it as y will be is equal to under the root x. Okay. So under the root x means negative also will come, but area cannot be negative. So you are going to take the modulus symbol. But here, since they have asked in the first quadrant, I am taking only the positive root x. So therefore you are writing y is equal to what? Root x. So here by writing x will be varying from 1 to 4. Y is nothing but under the root x into dx. Now let me integrate this one. You know, x root x can be written as x to the power of 1 by 2. So therefore, which implies that integral x will be varying from 1 to 4. Root x can be written as x to the power of 1 by 2 into dx. This implies that you can integrate this one, which is x to the power of n. X to the power of n integration is x to the power of n plus 1 divided by n plus 1. So therefore, x to the power of half plus 1 divided by half plus 1. You have to apply the limit. X will be varying from 1 to 4. Now first you have to apply the upper limit, and then you have to apply the lower limit. First let us apply the upper limit, which implies that upper limit is 4 half plus 1 divided by half plus 1 is nothing but 3 by 2. 2 ones are 2, 2 plus 1 is 3, 3 by 2. Correct. So minus, you are having applying the lower limit. Lower limit is nothing but 1 to the power of half plus 1 divided by 3 by 2. Now if you take 3 by 2 to the numerator, it will get 2 by 3. So therefore you can have, so 2 by 3 you can take common, 2 by 3 into, see, 4 to the power of 1 by 2, I am writing 4 to the power of 1 by 2 into 4. The base are same, you can add up the powers. 1 to the power of anything will be 1 itself. So minus 1. Now which implies that 2 by 3 into 4 to the power of 1 by 2 is nothing but under the root 4. Correct? Root 4 into 4 minus 1. So under the root 4 you know that it is nothing but 2. So 2 by 3 into 2 into 4 minus 1. So therefore 2 by 3 into 2 into 4 is nothing but 8 minus 1. So therefore which implies 2 by 3 into 7. So 7 2s are 14 divided by 3 is the answer. You can write if you want square units, because they are never given a units here, so that you are going to write it as square units, which is a area measured, right? So this is how you are going to solve the problem, dear students. Okay, we'll be moving on to the next problem. Find the area of the region bounded by y squared is equal to 9x, x is equals to 2, x is equals to 4, and the x-axis in the first quadrant. So same thing they have given y squared is equal to 9x. Here 4a is equals to 9 they have given, that's it. So you can take it out the same diagram. So what they have given? Given curve is a parabola about the y-axis, right? About the y-axis. Sorry, about the x-axis, right? Because y squared is equal to 4ax. So given is a parabola about the x-axis, which is a positive x-axis. So given curve is what? Y squared is equal to 9x. If you convert to y will be is equal to under the root 9x. So under the root 9 is nothing but 3. So you can have 3 root x. So y you can convert it as what? 3 root x. Now given lines are what? X is equals to 2 and x is equals to 4 are lines, isn't it? Are lines parallel to y-axis, right? As we drawn in the last case. So let us draw the diagram now. They have given in the first quadrant only. So therefore you can have here this is 0, 1, 2, 3 and then 4. So you can draw the curve which is a parabola about the x-axis, which is a positive x-axis. X is equals to 2. This is x is equals to 2, which is a line parallel to the y-axis, and this is x is equals to 4, which is a line parallel to the y-axis. So therefore region will be here in the first quadrant. You can take this is in the first quadrant, right? So here x is equals to varying from where? 2 to x is equals to 4. Now you can draw the stripes, which is the vertical stripes I am drawing. This is y and difference is nothing but dx. So area it is given by what? So area under the curve it is given by, so area is equal to integral x will be varying from 2 to 4, lower limit from left to right you are moving, from left to right. So 2 to 4, okay. So 2 to 4 y into dx. What is y? So x will be is equal to 2 to 4. Y is nothing but what? Y we have converted already 3 root x. So therefore you can write 3 root x into dx. Got? Now you can integrate that one, then apply the limit. Now what happens here? Which implies that, so 3 under the root x, that is x is equals to 2 to 4 root x into dx. What I have done here? I have taken what? 3 outside the integral, right? Which is a constant. So therefore 3 into under the root x is x to the power of 1 by 2, which is x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 from the limit 2 to 4, right? Now this if you take, you are going to get LCM as 2, 2 plus 1 is 3, 3 by 2. So therefore you can have 3 into x to the power of 1 by 2 plus 1 divided by 3 by 2 from the limit 2 to 4. Still you can simplify this one. 2 by 3, 2 will go to the numerator. So 2 3s are 6. So you are having 6 divided by 3 x to the power of 1 by 2 plus 1 from the limit x will be from 2 to 4. Now 6 by 3 is nothing but 2. So 2 into x to the power of 1 by 2 plus 1, correct? From the limit x will be varying from 2 to 4. Now you can apply the limit. So 2 as it is you are keeping, right? It is in the first quadrant they have asked you to calculate. X is nothing but applying the upper limit 4 first. So 4 to the power of 1 by 2 plus 1 minus lower limit is nothing but 2. X is equals to 2 to the power of 1 by 2 plus 1. Now you can simplify further. 2 into 4 to the power of 1 by 2 is 4 to the power of 1 by 2 into 4. Similarly 2 to the power of 1 by 2 into 2. Now this will become 2. 4 to the power of 1 by 2 is root 4 into 4 minus root 2 into 2. Again you can simplify further. 2 into 4 minus 2 into root 2. Now if you want, you can multiply 2 inside. So you are having 2 into here 8 minus 2 root 2. Otherwise you can have 8 2s are 16 minus 4 root 2 square units. Okay, and this is your final answer you are going to get for this question, dear students. I hope you understood this one. Now we'll be moving on to the next problem, dear. What they've asked. Find the area of a region bounded by x squared equal to 4y, y is equal to 2, y is equal to 4 and the y-axis in the first quadrant. Remember, dear students, they have given here y-axis. So the given curve also about the y-axis, which is a parabola. Already I have given you the diagram in the second slide. If you want, you can go through. So given curve is what? Given curve is x squared is equal to 4ay, which is a parabola about the y-axis, isn't it? About the y-axis. And here also they have given the first quadrant. So we need to calculate in the first quadrant itself. So what they have given next, y is equal to 2. X is equals to 2 and 4 means it is a line parallel to the y-axis. So opposite, y is equal to 2 means it is a line parallel to the x-axis. That's it. So therefore, y is equal to 2 and y is equals to 4 are lines parallel to x-axis. So let me draw the diagram accordingly. So parabola about the y-axis means you are getting. So this is what the parabola about the y-axis, and here it is a 0 and 1, 2, 3, x is equals to 4. Now y is equal to 1, which is a line parallel to the x-axis. Here y is equal to 2 they have given. So this is a line which is parallel to the x-axis. So y is equal to 2. Similarly, y is equal to 4. This is a line. Y is equal to 4. So therefore, in the first quadrant means what? This is the first, second, third, fourth. So first quadrant means this region we have to find out. Now here, I can have the horizontal stripes. So this is a region you need to find out, right? Here instead of the vertical lines, I am going to draw the horizontal lines because they have given already y from 2 to 4. So therefore, let me draw the horizontal line. This is a horizontal line you can see, and this is nothing but the dy and this is x, isn't it? So area will be what? So I can have area will be is equal to integral, what is that? X into dy. So x into dy means what is the varying? Varying y is equal to from 2 to 4. I am taking from below to the above. Okay. When you are moving on to the x-axis left to right. When you are taking about the y-axis means from below to above you are going to take it as. Okay. So therefore from y is equal to 2 to 4. Right. That's it. So therefore you can have now what is x? X in the given curve we are going to change it for x in terms of y. So they have given here x squared is equal to what? 4y. So which implies that what is x is equal to under the root 4. What is under the root 4? 2. Under the root 4 into root y. So 2 root y. So therefore this you are going to have x is equal to 2 root y. You can replace here. Y will be varying from 2 to y will be from 2 to 4. So x is nothing but 2 root y into dy. Now dear students, 2 is a constant. You can bring outside the integral which will become, which implies, so 2 integral y from 2 to 4. So under the root y means y to the power of 1 by 2 into dy. So therefore you can have here which implies that 2 y to the power of 1 by 2 is what? So y to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 from the limit y from 2 to 4. So therefore you can have here 2 into y to the power of, see this will become 1 by 2 plus 1 which is 3 by 2. 3 by 2 here, when we go to the numerator 2 by 3. So y to the power of 1 by 2 plus 1 from the limit 2 to 4. You can apply y is equal to 2 there. 2 2s are 4. 4 by 3 into y to the power of 1 by 2 plus 1 from the limit 2 to 4. Now you can apply the limit, dear students. Now which implies 4 by 3 into, see, y to the power of 1 by 2. Apply the upper limit first, which is 4 to the power of 1 by 2 plus 1. You know already how to take. Apply the lower limit, 2 to the power of 1 by 2 plus 1. Now you can simplify further. 4 by 3 into, this is root 4 into 4, because 4 to the power of 1 by 2 minus root 2 into 2, as we have written in the last case. Okay. Now you can have, which implies 4 by 3 into 4 root 4 is 2 into 4 minus 2 root 2. Now still you can simplify this one. 4 by 3 into 8 minus 2 root 2. If you want, you can simplify still further. 8 4s are, which is 32, minus 4 2s are 8 root 2 divided by 3 square units. Okay. And this is what you are going to get the answer, dears. I hope you understood this one. Now we'll be moving on to the next question. What they've asked: find the area of the region bounded by the ellipse x squared by 16 plus y squared by 9. So here x coordinate is greater than y coordinates here. See, 16 is greater than 9, which is A is greater than B. So given curve is an ellipse about the which axis? Yes, x axis. About the x axis. Why? Because here A is greater than B, which is implies 16 is greater than 9, or 4 is greater than 3. You can write it as A squared is greater than B squared, right? 16 is greater than 9, or 4 is greater than 3 if you remove the square root. So therefore, and what is the ellipse? You can write it as diagram. Diagram will come like this. So this is what an ellipse you are having, and this is an ellipse you are having about the x-axis. Now they have given, this is a center which is nothing but 0, 0. You can have here, they have given 16 means minus 4, 0, and this is 4, 0, right? And this is 9 means 0, 3, and here 0, minus 3, right? Now they have asked you to find out the area of the ellipse itself. So here I am taking this as O, and this is a point A, and this is a point B. Okay, if you see, you can see this area equal to this area, region, this region equal to this region equal to the 4. About the x-axis, about the y-axis, it is symmetric. If it is symmetric means, if you calculated this area 4 times, then calculated the whole ellipse area. It is equal to the whole ellipse area. Understood? So therefore, I am calculating only this region taking, and I am going to multiply 4. 4 times means you are having this region plus this region. Understood? So 4 times of this region gives you the whole area of the ellipse. Okay. Now therefore, what is the stripes I am taking here? Vertical stripes, if I am going to take it as, I can take from 0 to 4, because I have to see the x-axis. So I am going to take the vertical stripes here. So this is what the vertical stripes, and this is a dx, and this is a y. So x varying from 0 to 4 I can take it as. So first I am going to find out this area region, and 4 times of that I am going to multiply, which will be giving you whole area of the ellipse. Okay. So therefore, area is given by, area will be is equal to 4 times of, what is that? Y into dx. Now x will be varying from where? X will be varying from 0 to 4, right? They have given 0 to 4. Now here I need to convert for y by taking the curve. So let me convert that first, taking, what is that? X squared by 16 plus y squared divided by 9 is equal to 1 they have given, right? So is equals to 1, because area, it is the equation of the ellipse. X squared by a squared plus y squared by b squared is equal to 1, right? Now you can have, so I want to convert y in terms of x, means keeping y as it is, I am converting only y square divided by 9, I am going to keep it is here 1 minus, you can have x square divided by 16. You can take the LCM. So y square divided by 9 is equal to 16 into 1 is 16 minus x square divided by 16. Now I am going to cross multiply 9 y squared is equal to, see, 9 divided by 16 into 16 minus x squared. Now I am going to take a root to that side. So y is equal to square root of 9, which is 3, divided by square root of 16, which is 4, into under the square root 16 minus x squared. So y can be written as 3 by 4 into under the root of 16 minus x squared. So writing y as it is, you are getting, which implies 4 times of y. X will be varying from 0 to 4. Y is nothing but 3 by 4 into under the root of 16 minus x squared into dx. Now you can take 3 by 4 outside. So 4 into 3 by 4 into x will be varying from 0 to 4 under the root of 16 minus x squared into dx. Now 4 will get cancelled. You can have 3 times of x will be varying from 0 to 4 under the root of 16 minus x squared into dx. Under the root of a squared minus x squared is given by the formula x by 2 into under the root a squared minus x squared plus a squared by 2 into sine inverse of x by a, isn't it? So therefore applying that one, which implies that 3 into, you are having x by 2 into under the root of a squared, which is 16 minus x squared, plus a squared, that is 4 squared divided by 2 into sine inverse of x by a. So x divided by a is nothing but 4. Right, from the limit you are going to apply from x will be varying from 0 to 4. Okay. Now you can apply the limit after simplifying. It will be giving you, see, 3 into x by 2 into under the root of 16 minus x squared plus 4 square divided by 2 is nothing but 16 by 2, which is 8. So 8 into sine inverse of x by 4 from the limit x will be varying from 0 to 4. Now you can apply wherever x is there 4. First apply the upper limit. So what is the upper limit? Upper limit is 3 into, so 4 by 2 into under the root of 16 minus 4 squared plus 8 into sine inverse of x by 4 means 4 by 4. Right, minus lower limit. Lower limit wherever x is there 0. 0 into anything will be 0. Right. 0 into anything will be 0. Now again plus, see, 8 into sine inverse of 0 by anything will be 0. Sine inverse of 0 is always 0. So this will become 0. So lower limit full, it will be 0. Now you can have simplification. 3 into 4 by 2 is 2 into 0, because 16 minus 16 is 0, plus 8 into sine inverse of 1. 4 will get cancelled, 1. Now you know sine inverse of 1 is nothing but what? Which is pi by 2. Sine 90 degree, isn't it? So therefore further simplification, 3 into 8 into pi by 2. So therefore 2 1s are 2 4s are, which implies that, so 4 3s are 12 pi. This is your answer for this question, dear students. So this is what 12 pi square units, right? And this is your final answer. You are going to get it as when you solve that question, when A is greater than B especially. We'll be moving on to the next problem. Find the area of the region bounded by the curve x squared plus 5 plus y squared by 9 is equals to 1. Here if you see, x coefficient is lesser than y coefficient, or y coefficient is greater than x coefficient. Therefore, the ellipse is about the y-axis. So the given curve is an ellipse about y-axis, because here 9, that is a squared is lesser than b squared, which implies you can have root 5 whole squared is lesser than 3 squared, right? So, okay dear students, I hope you understood this session, how to solve the problems on parabola of the x-axis and the y-axis and also the ellipse. In the next session, we'll be moving on to some more problems, which is our exercise 8.1 from your NCERT textbook. So, keep watching. Thank you. Have a nice day, dears.